Hey there, and welcome back to The Explainer. Today, we're diving into a real adventure. We're not just going to learn about science, we're going to learn how to do science. We're stepping into the investigative world, where curiosity is your compass and every single question is a new door to open.
So let's just kick things off with a big one. What do you think? More grains of sand on Earth or more stars up there in our home galaxy? This is exactly the kind of mind-bending question that science just loves. It gets our imagination firing on all cylinders and makes us think, okay, how could we even begin to figure that out?
Because that's really the secret, isn't it? Science isn't some dusty old book full of answers somebody else found. No, it's a living, breathing process. And it always starts with those simple but super powerful questions. Why and how? It all begins with wonder. There's this path we all go on. When we're younger, we just kind of look at the world and go, wow. Then a little later, we learn that, hey, scientific ideas aren't set in stone. They can actually change and evolve. But today is about taking that next crucial step. It's about learning how you can become the investigator. We're making a shift from just knowing stuff to knowing how to find stuff out.
And to do that, well, every good investigator needs a toolkit. And right at the heart of the scientific toolkit, there are these two beautiful, simple, but incredibly powerful ideas that we have to keep in balance.
I want you to think about it like this. Science needs both a root and a kite. The root, well, that keeps us firmly planted in reality. It's all about what we can actually see, what we can measure, what's real. But we also need the kite. The kite lets our ideas, our curiosity, and our creativity just soar. It lets us ask what if and imagine totally new possibilities. The real magic, the best science, happens right in that sweet spot where we balance both solid, grounded facts and high-flying creative thinking.
Okay, so to see this toolkit in action, we don't need to go to some fancy multi-million-dollar lab. Nope, we can start somewhere way more familiar, your kitchen. And we're going to investigate a delicious, everyday puzzle.
You've seen this 100 times, right? A little flat circle of dough hits the hot oil and, poof, it inflates into this perfect, puffy ball. But why? What is actually happening in there? What's the science that makes it puff? And have you ever noticed how one side is always paper thin and the other is thicker? These are exactly the kinds of questions a scientist would ask. And here's our game plan for figuring it out. First, we've got our question. Next, we look at all the things we can change. We call those our variables. Then we decide what we're going to watch for. Those are the results. Now here's the golden rule, the most important part. You only change one thing at a time. That way, you know for sure what's causing the effect you see. And finally, you write it all down. It's a simple framework, but it is so powerful. So for our pories, what could we actually change? Oh, a ton of stuff. We could roll the dough thicker or maybe thinner. We could try different flours. What about the oil? Should it be screaming hot or just kind of hot? Even the way you slide it into the pan could change things. Every single one of these is a variable we could test one by one to see what happens. And you think, okay, after all this, the answer must be pretty straightforward. But here's the part that I think is so cool. Get this. The complete physics of why a pori puffs up exactly the way it does, well, scientists are still trying to figure it all out. It's a fantastic reminder that there are amazing mysteries hiding in plain sight, all around us, just waiting for a curious mind to come along. Okay, so now let's zoom out. Because this way of thinking, ask, change one thing, observe, record, it's not just for kitchen experiments. It is the fundamental logic that scientists use to understand everything, from the tiniest microbe to the entire cosmos. We use this exact same method to explore the invisible world teeming in a single drop of water. We patiently figure out which microbes are helping us out and which ones might make us sick. That same logic explains the huge, powerful forces of physics. It's how we understand the friction that makes a car screech to a halt, or the pressure changes that create the incredible power inside a cyclone. It's how we finally figured out light itself, by observing how it bounces and bends to make images. We even used it to track the light from the moon, which helped us design our very first calendars. And we can use this investigative approach to map out the incredibly tangled web of relationships in our ecosystems. We can see how the tiniest bug and the biggest whale all depend on each other to survive. And maybe, most critically right now, this is the exact tool we have to use to understand the urgent, complicated challenges that our entire planet is facing.
So here's the bottom line. The ability to observe carefully, to measure things accurately, and to experiment thoughtfully, that's not just for a class or for a test. It's the essential skill set we all need to understand and protect this incredibly delicate balance that our world depends on. The road from a puree to a planet is paved with the exact same way of thinking.
Which brings this whole thing right back to you. This way of thinking, this investigator's toolkit, it doesn't belong to some special club of people in white lab coats. Nope. It belongs to anyone with a curious mind. It belongs to you.
Because once you really get it, once you realize the fundamental method is the same whether you're looking at a puree or a planet, the whole world just kind of opens up. It stops being a place of boring, given facts, and it becomes this amazing landscape of fascinating questions. So, what are you going to investigate first?